Hi everyone, my name is Minqiang. I'm a senior staff engineer in Alibaba Cloud Database. In this video, I'm gonna introduce the multi-master architecture of our cloud-native database, PolarDB, and its evolutionary journey. In terms of cloud-native database architecture, I think there are three most typical features. First, resource separation. A typical feature is storage-compute separation. We can see there are many popular commercial databases adopt this architecture. Second, resource pooling. In general speaking, is the distributed storage. The storage resource has a limitless pool that could be retrieved by the app layer. And the last core feature of cloud-native database is data sharing. In the traditional database architecture, both master and replica nodes request individual duplicate storage. The first generation of cloud-native database architecture decoupled computing and storage, and enables the storage of data sharing between master and replica nodes. Therefore, the databases can do quick read scaling and don't need to duplicate storage for reading. But in the architecture, the data still can't smoothly transfer or shared between the multiple master nodes, which result in multiple data silos and limits in write scaling. In the second generation, that's the architecture that PolarDB adopts right now, is the multi-master cluster that pulls the data in the cluster, allowing data sharing within the master nodes of the cluster. It breaks the data silos, allowing the data smoothly retrieved and shared by any of the master nodes, and conquers the write scaling bottlenecks. In the practical use case, it reduces the complexity of database maintenance and save resources. Let's take holiday season online sales as a practical use case. Once the sales get started, the user's transaction and the view traffic can hit hundreds of times than normal in seconds. And when the sales get over, the transaction and the traffic can quickly drop down as well. In this kind of scenario, we can see the advantage of cloud-native database stand out. Firstly, the write scaling can be done in second level. That makes the multi-master cluster can just scale out to add multiple numbers of the read-write nodes within 1 second before traffic started, and also scaling in minutes after sales end to support the traffic with extreme efficiency. Secondly, multi-master back up each other to save the replica nodes resources. For many years, the master replica architecture has been the classical architecture of database. To keep a high availability, the traditional approach usually prepares replica nodes with individual storage that back up for the master nodes, which cost extra resources. But in multi-master architecture, the data sharing in storage layer allowed any master nodes can access to all the data. So master nodes can back up each other, and it eliminated the replica nodes for saving storage and computing resources. The third major improvement is that the aggregation query that cross databases can be more efficient without creating an extra aggregation database. PolarDB Multi-Master offers global read-only nodes that can access the shared storage, which means it can access all the data to support aggregation queries. The global read-only nodes and the global binary logs boost the cluster aggregation more efficiently. Let's take a look at the performance test.